Good morning, grade 9, your advisory. Morning, online students. Let's have the continuation of our topic, the discussion, respiratory system. Where did we start? Did we stop last meeting? Where did we stop last meeting? Huh? Where did we stop last meeting? Yeah, the okay. We stopped last meeting in alveoli. Let's continue now with the lungs, correct? We are now in lungs. Please get your science notebook and take down notes. You take down important details or important terminologies because this will come out in your exam. Mind you, I am done with your first periodical or quarterly examination, and it is 60 items, all in all, including circulatory system. So the coverage are, or did you know already the coverage, correct? I already sent it via GC. Okay, the coverage are from circulatory system down to respiratory system. Okay, let's have lungs. So what's with the lungs, right? The lungs are large spongy organ. This is spongy because it collects oxygen in the process. Okay, it actually collects oxygen by diffusing it. Okay, in their walls, in their epithelial walls, right? Located on the thoracic chest cavity, thorax or thoracic chest cavity. This one. Okay, they occupy most of the space in the thoracic cavity, which is separated from the abdominal cavity by a large flat muscle called diaphragm. So what separates your abdominal or your flat muscle, or abdominal muscles or cavity are your diaphragm. Okay, it separates the digestive system and the respiratory system because your diaphragm acts as a pump. Okay, the diaphragm performs an important function in breathing. Okay, when diaphragm contracts and pulls downwards, the lungs expand. Okay, and air enters the lungs to inhalation. Okay, it expands. So if again the diaphragm contracts and pulls downwards, if it pulls downwards, tendency is it enables the lungs to what? To expand, to occupy more air in the process. This is the main reason why when you sing, okay, especially in choir, they're using diaphragm rather than vocals because they need more air in performing those. Okay. When the diaphragm relaxes, air is exhaled from the lungs. That's the mechanism of breathing. Okay, that's how we breathe, right? Do you have any questions so far? Please take down important details. Okay. So this is your lungs. As you can see, this is your diaphragm. Okay. When it contracts, when this contracts, what happens? The happening there is it will pull the lungs. Okay, to accommodate more air so that we can get more oxygen in the process. And when it relaxes, it what? It will exhale, we'll be doing exhalation or expiration, do exhalation to eliminate carbon dioxide or waste products. Okay, each lung lies in the pleural cavity, right, which provides a hollow space in the lungs to expand into during inhalation. Okay, the pleural cavity is lined with double-layered membrane known as pleura or pleural membrane. So your lungs is actually covered, okay, with pleural membrane. Okay, it has pleural membrane. So that is the protection of the lungs. It has also protection in your heart area. That is the main reason why your right or your left, okay, lung is smaller than your right lung because of the cardiac notch. The cardiac notch protects, again, it protects also the heart because the heart is still moving. And remember that your lung also will expand in the process. So that is their protection. The pleural cavity there, okay, or pleural membrane, it is actually covered with the pleural membrane. That is for the lungs protection also. Remember that your lung is a hollow organ. It's a hollow organ. Now, if you're going to dissect lungs, if you're going to see the actual lungs, you can actually see that it looks like a plastic. That's it. A hollow plastic. Okay? And you cannot preserve that one because, again, it will just shrink. That's how hollow the lungs or these lungs are. Okay? The inner membrane, also known as visceral pleura, okay, lines and surround lungs, while the outer membrane is also known parietal pleura, okay, which actually runs along the surface of the chest cavity and diaphragm. Okay, please take down again important details. Okay. Between the pleural membrane is a thin fluid known as pleural fluid, okay, which provides lubrication as the lungs expand and contract during breathing. Okay, it has a what? Pleural fluid. That is for lubrication. When you see lubrication, it enables, okay? It protects the lungs against frictional force or friction. So to prevent friction from happening, because again, your lung always expand, contracts, when the diaphragm contracts, it expands, and when the diaphragm relaxes, it also shrink or shall we say become smaller. So because there is movement there, tendency is there is always friction. Because we have pleural fluid in between these pleural membranes, tendency is we eliminate friction during that time. Or we eliminate friction there. Okay? We put lubrication. So God already put lubrication there. The lungs vary in size. It depends upon the left lung is slightly smaller than the right lung because two-thirds of the heart is located on the left side of the thoracic cavity. Okay. The left lung also contains cardiac notch, the one that I am telling you a while ago, and the one that I'm telling you during our discussion with the circulatory system. Okay. An indentation in the lungs or in the lung that provides a room for the heart. Because again, your heart is moving. Okay. Now, if you don't have cardiac much, tendency is it will actually what? Go in touch with the heart. Okay? And we tend to what? To have friction. And of course, your organs will be damaged. Okay? In the process. Please take down notes. As what I had observed also, these cardiac notes usually occur or usually comes out during these bolts. That's what I had observed. Small details. Isha and Blair are still with us.
Yes, sir.
Isha and Blair,
Yeah,
are you still with
yeah.
us? Can you hear us? Okay. Okay, let's move forward. So, as you can see, this is your left lung and this is your right lung. So, it is slightly smaller. Okay. Your cardiac notch is located here. Okay. This is a room for the heart to move. Okay. Your lung is actually divided into lobes. Okay, we have superior, middle, and interior. So it is just easy. Okay, superior, middle, in the middle, and the interior, which is in the lower part. Okay, let's move forward. Each lung consists of several distinct lobes, which are separated by horizontal and oblique fissures. Right lung has three lobes. We have superior lobe, okay, middle lobe, and inferior lobe. Okay, the horizontal fissures separates the superior lobe and from the middle lobe, while the right oblique fissure separates the middle lobe and the inferior lobe. This one. These are fissures. Okay. While the right oblique fissure separates the middle lobe and the inferior lobe, the left lung has only two lobes. Okay, we have separated by left oblique fissure, superior lobe and inferior lobe. This one. Superior lobe and inferior lobe. So we have two again. Distinction or part of the left lung simply because there is cardiac lungs there. Right? Questions so far? Questions? Let's continue. In the lungs, red blood cells carry oxygen into the bloodstream and is distributed throughout the body. Likewise, red blood cells collect carbon dioxide in the process and carry it back to the lungs where it is expelled out of the body during exhalation. Okay. The breathing mechanism. Let's take a look at how we breathe. What are the mechanisms of breathing? Okay. Through breathing, oxygen and carbon dioxide are exchanged between internal or external environment rather and body cells. External environment. So we actually get oxygen in our external environment. Just say that we cannot actually create oxygen in the process. Remember that oxygen is a byproduct of photosynthesis. Okay, it is a byproduct of photosynthesis. And remember that the number of oxygen in the atmosphere is lesser than the rest of the elements or gas in the atmosphere. It should be created by a biological being or autotrophs or producers. Breathing is a physical process of getting air through inspiration. So when you breathe, it is actually inspiration. And when you breathe out, okay, it is called expiration. Inhalation is equal to inspiration. Exhalation is equal to expiration. That's the other term. Okay. Inspiration. Inspiration is also known as inhalation. Okay. The movement, it is the movement of air from the external environment from the outsource to the airways and into your alveoli. From the outsource to the alveoli. So outsource, outside source, your nostrils, okay, going to your alveoli in your lungs. Okay, that's inspiration or inhalation. During inspiration, the intercostal muscles, these are muscles attached to the ribcage, helping form and move the chest will contract and move upward. Rising chest cavity, your ribs or sternum, this is your ribs. Okay, your ribs, your sternum. Okay, at the center is your sternum. That is called sternum. Okay. Likewise, the diaphragm contracts and moves downward. Okay, when the diaphragm contracts, it actually moves downwards. It what? It pulls the lungs also downward to expand. Okay, expanding the thorax and reducing pressure. The air from outside rushes through the airways and into your lungs. Okay, that's how we inspire or inhale. That's inspiration. Okay, let's have expiration. This is not the expiration way. This is the way you exhale. Okay, it is also known as exhalation. Okay, it is the movement of air out from the lungs and into the external environment. If inhalation is from the external environment going to your lungs or your alveoli, expiration is the opposite of it. It is the exact opposite because You are now moving out air to your external environment. Okay? You are expiring what? CO2 in the process, or carbon dioxide. Okay? During expiration, the intercostal muscles contract, lowering the chest cavity, compressing the thorax. The diaphragm relaxes, okay, and moves upward, causing the compression of the lungs and the outward flow of air. Exhaled air contains carbon dioxide or CO2. Okay, that's how we exhale or expire. Questions so far? Are we okay? Why? So fast? Let's make it slow.
I'm so confused.
Why?
Still speaking, I'm so confused.
You're so confused? Why? What are the concepts that you are so confused, by the way? You're confused in how you
What
breathe?
do you mean?
Terminologies? Okay, what terminology?
Uh,
All terminology? Okay, again, when you inhale, you expire. That's the terminology. Exhale, then you expire. What else? What are the other terminologies that you find it confusing? There's no confusing words in science. They're all specific. Science is really specific. And take note, they're always evolving. The terms now will not be the terms in the future. Because again, there are some advancement of technology. What are the confusing words there? Intercostal muscles, these are muscles that control your thoracic cavity. That's the intercostal muscles. It controls your thoracic cavity, thorax. So when you inhale, you listen, when you inhale, okay, so you inhale, everybody, inhale. What have you observed? What have you observed when you inhale? Your chest, okay, your thorax, your chest cavity expand also because you inhale, correct? The expansion of your chest cavity is actually driven by your intercostal muscles. It's actually attached to your rib cage. So don't make it complicated. It is just, it is. Okay, it is a muscle that controls the contraction of or that controls your rib cage or your chest cavity. Okay, any other term aside from that? Respiratory rate. Okay, in hospitals, we usually coin respiratory rate with RR. Okay, that's the abbreviation. So let's have the abbreviation first. The will not be confused. Okay, BP is blood pressure, right? RR is respiratory rate. Okay, what else? These are the vitals. Um, E/M is pulse per minute. Those are just few. And those are the vitals. RR. Let's take a look at what is respiratory rate. Okay, respiratory rate is the number of breaths taken. Okay, yeah. Um, BPM, beats per minute. Okay. Respiratory rate is the number of breaths taken within a set amount of time, typically 60 seconds. So how can we check on the RR or respiratory rate? So one count is, remember, the number of breaths taken within a set amount of time. So when you breathe, that's 1, 2, 3. That's respiratory rate. Okay. Your doctors, if you got into a checkup, especially those students or babies that has pediatrician or pedia, they tend to look at RR as always. Okay, respiratory rate. They tend to check also your lungs. How do they check lungs? By the use of stethoscope. Okay, they will be checking on your lungs if there are some what some phlegm in your lungs. Okay. Human respiration rate is measured when a person at rest and involves counting the number of breaths from 1 minute by counting how many times the chest rises. That is actually respiratory rate. Okay. The average respiratory rates by age are as follows. These are the average respiratory rates. Okay. Birth to 6 weeks. Okay. We can actually observe that it is from 30 to 60 breaths per minute or BPM. RR. 6 months, we have 25 to 40 beats per minute. Okay. 3 years, we have 20 to 30 breaths per minute. Okay. 6 years old, we have 18 to 25 breaths per minute. 10 years old, we have 15 to 20. And for adult, we have 12 to 18 breaths per minute. So what had you observed there from here down to the adult? What have you observed? Hmm? Decreasing. It is decreasing. Why? What do you think is the main reason? Why it is decreasing? You have babies at home, correct? Do you have? Okay. So why babies has a bigger RR compared to the adult?
They're long,
Huh?
they're long,
They're
they're long.
yes, you have a point, Joel. Their lungs are still small. Okay, it needs to accommodate a lot of oxygen. What else? Their respiratory system are still in the phase of development. Okay, remember that inside the womb, lungs are not actually doing something there. Okay, you are floating in embryonic fluid. Okay, and your lungs there don't have use at all. So once you are out, okay, of the sac, embryonic sac, your lungs will start to inflate. Your respiratory system starts to move. Okay, since it is still developing and it needs a lot of oxygen in the process, it needs to accommodate more oxygen to supply the need of the body. It needs to perform 30 to 60 breaths per minute. Even the heart. Okay, babies has faster heartbeats compared to adults because it needs again to accommodate more oxygen in the body. So do not be confused if the babies at home or your siblings has faster heartbeat and has faster also RR or respiratory rate. Because again, they need to do that in order for them also to accommodate more oxygen. Okay? Rates may increase with fever, illness, and other medical conditions again, because if you are fighting some conditions, your body need to prepare itself. That's the defense mechanism of the body. Okay? Like for instance, if you have cough, okay, you need to have a faster RR. Because again, your body is being attacked, especially your lungs. okay, with foreign bacteria. And some of the alveoli there are not working. So you need to have a faster RR to accommodate the oxygen needed by your body. Do you have any questions so far? Question? Okay. I think we are done with the respiratory system. We had just discussed everything. And let me check the time. Okay, it's almost time. Well, definitely, let's take a look at the connection between your respiratory system and your circulatory system. How do they relate? They carry oxygen, yes, probably because circulatory system is carrying oxygen also in the process, which was collected by the respiratory system. What else? What else? What is their connection aside from the oxygen? They carry oxygen. What else? Huh? You don't know? You will know during the exam because it is there. You don't know? Aside from carrying oxygen, how about waste materials? How about your CO2, which was collected by your systemic circulation, going to the pulmonary circulation? Okay? Your lungs or your respiratory system also act as what? Waste eliminator of CO2 from all the systems, all parts of your body by pulmonary circulation. What else? It regulates, okay? It regulates the amount of oxygen in the body. Why it regulates, sir? Remember that your BPM, your RR, is connected to your circulatory system because again, they what? They supply oxygen in the process. So we have, okay, take a look at this one. We have a specific, okay, oxygen level. We need to maintain a specific oxygen level in our body. Okay, it should be it should be 20, no, it should be 90% up. It is called the O2 saturation. Please take down notes. Okay, O2 saturation, that is actually the term for what? The oxygen level. Oxygen level in our body. We need to maintain at least, take note, at least 90% up of the oxygen level in their body, which is called the autosaturation. Okay? Autosat or autosaturation. Your autosaturation, sir, how can you check our autosaturation? Have you observed the medical instrument that is actually placed in your finger? Okay? It is called autosat or autosaturation. Okay? It will give doctors and medical interns the oxygen level in your body. Sir, how about if it will becomes below 90%? Okay? If it will become or it will be in below 90%, you will be supplied with oxygen. Okay? If it is 85%, you will be supplied with oxygen through nasal cannula. Have you observed the nasal cannula? The one that they actually place in the nose and oxygen? Okay, it is called nasal cannula. The nasal cannula will give supplementary oxygen, okay, to your respiratory system to accommodate again the need of oxygen. Do you have any questions so far? You sure? Are you ready for the exam? Your exam is fast approaching. That's next day, correct? 17, 18, and 19. Okay? So we'll be having that one face to face. All the subjects will be face to face. See? Did you check your schedule? All the subjects are there face to face, right? Okay, all the subjects there are face to face. That's why we have 3 days. Okay, you need to prepare yourselves. How to study science? You extract all the terminologies there. Simple as that. Okay, sure. We didn't actually copy all when we had our discussion. Remember that your slides are just in your LMS. I just again access the LMS. You just need to download it over. It's okay to download. It's okay to put it in your phone. Okay, at least you can browse. Okay, it is in PPT form. Okay, or a PowerPoint presentation. Yes, yes. Some of them are not in your book. I know. We need to have also external resources with regards to scientific ideas. You cannot rely on one um author only. You should have a lot of resources. Okay, so that we can expand also our knowledge. Cannot just put ourselves in the four corners of the room and it's as easy. No. Or all your lessons here are connected. Okay, it just looks like a puzzle, so we need to connect it all. Question so far? Question? Okay, please stand for the prayer. I think that will be all. Nicole? Thank you and goodbye, class. Arrange your chairs to take your seats. Just wait for other teachers to come.
Other teachers.
By the way, where are your clear books? I am asking you to bring all your clear books, correct? The purpose why do we have our clear book